All right, welcome everybody to a brand new day of IS50A. Today we are going to be working on elevators and maybe adding some snazzy little things to make a cool little elevator. So we've got all this real estate on the top of the building up here, and we need an elevator to get up to it. So let's go ahead and do this. So make a new blueprint class. It's going to be an actor, and I'm going to call this elevator underscore BP. Some people might call this a BP elevator, and that's fine as well. So we're going to need a couple things. We're going to need a starting point, we're going to need an ending point, and we're going to need the actual elevator itself. Maybe we could have like a spline, like a curved path that moves along for like more complicated, like sequences, like a thing sliding around like this. But I think we're just going to start with just a really basic like platform elevator. So this guy will be 0.2 tall, 0.1 tall, something like that. We do a chamfered cube. That'll make it look a little bit more. See the little edges there? I'll kind of round it off. It'll look a little more professional that way. 0.05 maybe. Yeah. And then for the material, what material, guys, do you think we should have for our elevator? Do you want a golden elevator? Does that sound exciting to you? A gold elevator? Camera speed's too high. You guys like that one? Or maybe steel? Chrome. Like that one better? I think burnished steel. That looks kind of cool. Put your votes in now. Which one do you guys like? Gold, chrome, or burnished steel? Chua, McKinney, what do you guys think? I'm kind of going for the burnished steel look myself. So. All right. Do we want to simulate physics? No, because this thing is definitely going to be violating the laws of physics. It's going to be moving up and down. So I'm going to compile this, and up here, when we begin play, we are going to save our location. Maybe our location will be the start point, and then the end point could be set. Maybe. Yeah, it makes sense to me. Okay, so we are going to get world location of the cube. Let's just do it this way. Get world location. And this we are going to promote to a variable, and that is going to be our starting point. So starting location. And the reason why this matters, and I'm going to make it visible so that we can feasibly edit it later on. The reason why this matters is because we're going to be moving the elevator around, and we always want it to kind of come back to its place where it began. If you do a lot of things where you move forward a centimeter, move forward a centimeter, move forward a centimeter, move back a centimeter, move back a centimeter, move back a centimeter, there's always a possibility that it doesn't quite come back the same number of steps that it went forward, because frame rates change and floating point numbers accumulate errors and things like that. So I always want to sort of return back to a known position that's good. And so I'm going to save the starting location when the game begins. And then what we're going to do is maybe make it so that when the player steps on the elevator, it'll go up. Maybe if we have time, we can make it so the user could use the elevator, or maybe we have a button that when you hit it, it turns the elevator on, something like that. But at the most basic level, let's just add a zone on top of this. We're going to add a zone on top of this that's going to be a child of the cube, so it's going to move with it. And this is going to be a box collision. And this will be the elevator like that. And we will move it So you have to step on the elevator at least a little bit. It's not going to start moving right when they step on. They got to move on a little bit. Okay, it's all centered properly. Cool. Okay, so the elevator trigger will actually move with its movable good. The cube itself is movable good. Okay, so this trigger, because it's a child of the cube, as the cube moves, watch this. So the elevator platform is going to move up and down. You can see the trigger zone moves with it. And that's good, because what we're going to do is say when the player leaves the elevator, it's going to return back. It's going to return back home. Okay. So at our most basic thing, it's going to be sitting on the ground. We walk over it. It'll take you up to the top. And then when you leave, it'll reset back down. Maybe we wanted to wait for the player at the top or something. But I think that's where we're going to start with and see where the spirit takes us from here. Okay. So on begin overlap, the first thing we're going to do, of course, is we'll just print a string, I guess, before we do anything else. Hello, why not? Okay. Compile, save, and we are going to toss the elevator out here. Ooh, that's actually really small, so maybe we can scale it up a little bit. And then we can start the player maybe a little bit closer, so I don't have to constantly walk over there. I'm just going to slide the player this way. Player's got a flamethrower coming out of their chest by default also, just kind of fun. Hey, walk over here. Hello. Great. Neat. Okay. So that works. Always test your collision settings, because there's always a possibility of things going wrong. And you always want to check the... anytime you have an event hit or an on overlap or something like that, you always want to make sure it's actually popping off. Otherwise, you're going to code all this stuff, and then when nothing happens, it's going to be kind of annoying to debug. Okay, so on overlap, what we're going to do is we're going to move up to the top of the world up here. So there's a couple different ways we can do this. I'm actually just going to do a... I'll just do a target point. I kind of like this approach. So this guy's location is 540, 0. So I'm going to come over here and hit paste, but I'm going to up the target points vertical. The reason why I did that is I don't want the elevator like sliding sideways kind of as it goes up. I just want it to go up vertically. So I just copied the location, pasted it onto the trigger point, and then I'm just going to drag it up to right around here. And that should be about right. You can fine tune that later. And what I'm going to do is name this elevator. I hit F2, by the way, for that. Elevator end point. And what I'm going to do is, the sparkly fog, I changed the particle size, by the way, if you're wondering why that was open. Just particle, I made the points a little bit smaller because they're kind of, yeah, why not? Okay. So, our starting location, and then our ending location is going to be that target point. So we're going to add, yeah, let's do it here, I guess. So we'll add a ending location, end spot, let's call it. And this guy is going to be of type target point reference. That, make it public, of course. Compile, save, and then our elevator can now be hooked to the that point right there. Depending on how you want to do it, you might make it a component of the elevator itself. And then with the elevator selected, you could like place its endpoint. Kind of depends on how you like organizing things. I've been doing kind of things this way. You could get into a situation where you got like just a ton of like target points everywhere and it's hard to keep track of them. So I could see there being an objection to the way of doing this, but this works decently well, at least for my needs. So what I've got here is I've got a variable called endSpot, and what I'm going to do is I guess I could just grab the ending. I guess I won't make that public. I'll just make a new variable called inSpot. Do this even simpler. So I'm going to drag out inSpot, get inSpot. I'm going to convert this to a validated get, because one of the things that students always do is they always forget to actually set the variables. They make a public variable like this, and then they forget to actually go out into the world and choose here which target point is the end of it. And then they get all these error messages and things like that. So a validated get is a great way of making sure you don't break your code. So we're going to say get is not valid, print string. We're going to say, bruh, you forgot to set the end location on an elevator. That's a great way of just reminding you of it. And if you do that, then we just, I don't know, delete ourselves or something. I don't know, destroy actor. It seems like a maybe overkill. I don't know. But if you don't, the elevator is just going to sit there. So I don't know. I don't know which one's better. Anyhow, so we've got our end spot here, and we are going to get its world location. Or get actor location, maybe. Okay. And this we are also going to promote to a variable. And that is, if it's valid, we are going to save its address into a variable called ending location. So when the elevator begins, it only has to do this once. When the elevator begins, it gets its location and saves it in the starting location. When if the end spot is set, if this spot up here is set properly on the elevator, then it is going to save that as an ending location. If it's not set properly, it prints an error message and quits life, right? And so we don't have to keep getting these locations anymore. And in fact, when nothing's happening, it'll just sit there and chill. We don't even need event tick exactly. Okay. So, but when the player steps on it, then we are going to animate from the beginning to the end. And so we're going to need a variable probably for duration, elevator ride duration. I don't have anything for you. Sorry. We'll make that a public though, so that the person doing the level design can choose how fast essentially the elevator is going to go. Elevator duration. Yeah. I want to put that into a timeline. Yeah, we will do a timeline. Maybe we're not gonna. Maybe we're not gonna use that. Okay, so we're gonna create a timeline. I never remember the add timeline. There it is. Thank you. This is Q. Thank you. Double click on the timeline. That's something that people always forget about. Like, how do I actually get into the timeline? You double click it, and it takes you in there. The timeline is going to be called. We're going to do a flow track. How do we want to do this? There's always different ways you can do these things. Yeah, I'm going to do a flow track. I like for my timelines to just go from 0 to 1. And how long it's going to run for could be variable. Loop. All right, I'm just going to add a key here. And so at time 0, it's going to be 0 inches off the ground. And then maybe at time 3, you can add a key. And at time 3, it's going to be 1 off the ground. In other words, it will it'll produce a number from 0 to 1 over 3 seconds. And this might even should be just 1 and 1, but I'm just going to go with this for now. So this is the elevator rise percentage. Sorry, I don't have good variable names for you. So coming back here, what's going to happen is when the player steps on the zone here, it's going to hit play on this timeline. And then this elevator rise percentage is going to go from 0 to 1 over the span of 3 seconds. And so we can actually just print string. It's going to screw up the duration. Thank you. Not you. Here. And so basically, when they begin overlapping, it's just going to print. It's not going to move yet. It's just going to print a value from 0 to 1 over the span of 3 seconds. And then when the player steps off of it, the event end overlap, we are going to reverse. And it's going to count back down. Direction. Okay, that is good. Okay. BP, compile, save, run. Okay, so when we walk on here, you can see we get a number that goes from 0 to 1 over 3 seconds, and then when we walk off, it will go back down. All right, dude. All right, here we go. Okay. You might notice that it didn't immediately rewind. The reason for that is because the timeline is actually 5 seconds long, so it's actually staying at 1 at 5 seconds. So 2 seconds from now, it'll start counting down. And is that deliberate on my part? Sure. Why not? So because it's a little weird for an elevator to immediately reverse course. So you write it up, and then you get off, and it'll pause for a second, and then it'll go down. All right. So now that we got that working, that's all good. And you can mess with these things as much as you want. Like you can add, like you can convert these. You can, like right now, it's just going to be a very mechanical, just linear going up. A lot of times we do these things called splines, and you can kind of adjust the, it goes up very quickly at the beginning, and then it overshoots and comes back down. Like, I don't know, that sounds like kind of fun. Maybe we'll do that. It's going to be weird because it's going to go over the building and then settle back down. But yeah, you can really play with these different kinds of curves and things like that, and get an effect that you like. Because a purely linear curve is purely linear line is not very natural feeling. So what we're going to do is we're going to set our location based on a lerp between the starting location and the ending location using the elevator rise percentage as the lerp. So a lerp means linear interpolate, and so it's going to, at 0, the lerp will return the starting location. At 1, it'll return the ending location. At 0.5, it'll return a point halfway between the beginning and the end. And so as elevator rise percentage goes from 0 to 1, which is why I like outputting a number from 0 to 1, because you can feed it right into a lerp, it'll smoothly interpolate the position of the elevator from start to finish. So we are going to, I guess we can get these values here. Starting location, get. We're going to do ending location, get. And we don't have to validate these because they are already sort of validated, sort of above. And what we're going to do is we are going to lerp between them. We're going to do a vector lerp. Normally we lerp between 2 floats. I just like saying the word lerp a lot. And so it's going to linear interpolate from the starting location to the ending location. When alpha is 0, it's going to return the start. When alpha is 1, it's going to return the end. And then, like I said, 0.5, it'll take a spot halfway between beginning and end. And then we're just going to set our location of the cube. So we are going to drag out the cube. And we are going to set world location. Yeah, it's not going to need to rotate unless we're doing something weird. I don't know. Maybe we can make it rotate. So we're just going to do that. Off has effect. Pull apart. Yeah, let's try this. Let's try this and see how this works. Okay. Yeah, it kind of like overshot a little bit and then went down. And then when it's in reverse, it goes up a little bit and goes down. So that, honestly, not bad. We should probably move that target target spot down just a little bit. Try that. Whee! Overshoot. And then boom. Nice. Goes off. It's a little weird that it pops up a little bit and then goes down. But yeah, you can see that curve. We had it going really fast at the beginning. And so it kind of makes sense for it to overshoot the target. I kind of like it. I'm gonna stick with that, even though the rewind doesn't make sense. It should just go down. You know, something like that. I am a-okay with this elevator. Okay. One more time. Cool. All right. Or we could have a different timeline for going down. That'd be kind of fun. I like this. This is cool. This is good enough. Okay. So what else can we do with an elevator? So we can make it so that, like I said, the user has to use the elevator. We could have it glow when somebody activates it. That would be kind of fun. Rodell, McKinney, what do you guys think? Do you want to see like how to use items, or do you want to see how to make an item like glow when it activates or something like that? No. Use item. Okay. All right. Use item. Okay. So in that case, I mean, I kind of like just stepping on it right now. Okay. So here we've got this guy, right? Like this light switch here. And right now that light switch, if we go to here, the light switch just activates when you bump into it. But it would be nice if you could activate the light switch by hitting like E, right? And E is the generic use command in video games. And so maybe maybe like when you use the elevator, it goes up. And then when you use the elevator again, it goes down. Although I don't know how you'd use it again, because it's going to be up there and you're going to be down here. Maybe you step on it to go up, and then you can hit use on it to make it go down. What do you guys think? These are all possibilities. I'm just kind of like thinking out loud here. I kind of just create these things as the whim suits me. So all of these things we're going to need is going to need something called a blueprint interface. Okay, and the blueprint interface is going to be called use BPI. Okay, and so the use BPI is going to create a new function, which we're going to rename, and it's going to be called use. Okay, and you can't drag off this or anything like this. What this is you know, when the user hits use on us or something like that. Okay. Inputs we could, but we're gonna do the input system. Okay. So this blueprint interface is going to be shared by every object that's usable. Okay. So if we have a light switch that's usable, if we have an elevator that's usable, if we have a monster that's usable, all of them will need to inherit from the blueprint interface. And what this does for you is it gives you a really nice unified way of using things. Because let's set up the use first, and then you'll see. Okay, so third person input actions, jump, move, weapon one. Let's do fire. Copy paste. As always, we're gonna do input action use. Open that up, and this is going to be player hits the use button. I think that's fine. Save. Thank you. Go back up here, IMC default, and mappings, we're going to add a new mapping for IAUs. And the mapping, click on that, is going to be the E key. Nope, not the left control, E key, thank you. And we will hit save and close out. So now when we come over to the player, this is BP third person blueprint, we can add a new input thing here for use. You can see here we've got all these kinds of things. We're gonna make a new one for use, which you can see the BPI that we made is popping up there. That's why I was kind of like, I don't know if I want to name it that, because you're gonna see a lot of use. Maybe I don't know. I got no better names for you. Event actor, where is it? Action use, IAUs, there. Okay. So when the user hits E, it's going to do this thing, and it'll give us true or false if it's used, which it will be. So just do a print string real fast. Hello. Compile. Save. Run. Hello. All right, cool. All right. But it's hitting it a lot of times, actually. So let's do started instead of triggered. And compile and save and run. I only wanted to print hello once. There we go. Hello. Great. Neat. That's exactly what we wanted. Okay. So now when we do this, we are going to do a trace line. So how far should we be able to use a light switch? How many meters away should we be able to hit the E key and the light switch turns on, or the elevator turns on? Like we'll need a use range variable for this. What do you guys think? How many meters? 2. Okay. So when we hit use, we are going to shoot a trace line, an invisible line through the world in front of us, and we're going to try and using that blueprint interface. Any object that implements use will be used by us. And so if you didn't have this, what you'd have to do is do like a trace line and line trace by channel, and then be like, if we hit an elevator, do this. If we hit a light switch, do this. If we hit, and that's kind of janky, I guess. So what we're going to do instead is we're going to get our location. Do we have any flamethrower? Can we not turn that on by default? Auto activate? No. Okay. Don't automatically spit fire, but when we click, it'll activate. Okay, fix that. That's been annoying me. All right. Do we have gun shoot point? Sure, that's a good point for our trace line to come out of right there. And the forward vector is red, so everything is set up cool for that. Gun shoot point, drag that out. And that is going to be location. That is going to be the starting point for our trace line. And then the ending point is going to be our gun shoot point plus the direction we're looking times the range. So we're going to do get range, and we're going to get our forward vector. So we're going to add, so basically, if you think about it, gun shoot point, our starting point is going to be here, our ending point is going to be here, plus the direction we're looking times 2 meters, 200. So our forward vector is there, our range is here, and we're going to multiply these two things together. The types are going to be wrong because Unreal Engine 5 has changed how this works, which is kind of weird. There we go. So forward vector times 2 meters, cool. And then we're going to add that to our starting location like that. And that is our end location. And then now we're going to turn on draw debug for duration and duration visibility. And we're just going to see, did we do the math right on it? If you don't do the math right, you're going to see lines going out to infinity or something. There we go. Okay, so that red line there is anything usable in that. Okay. All right. Thank you. Anything usable. Did I die? So anything usable within that range, it'll use. All right, so cool. We can turn off the draw debug. That seems to be working right. Always make sure that you rotate around and look in different directions to make sure that you didn't break something. Sometimes your trace lines will work right in one direction, but on another. Or it'll always trace line towards the world origin. Like if you forget to hook up one of these things here, it'll always draw a line from you to the world origin, which you have to watch out for. Okay, line trace. So here is the, did we hit something? So if we hit something, the first thing that we hit, we will try to split this. Okay, so if we hit something, then the actor that we hit here, we are going to use. That's what's so cool about the blueprint interface. Okay, so if the person does not implement the blueprint interface, it does nothing. Cool. So you hit use, you hit the landscape, nothing. You hit use, you hit a wall, nothing. But if you hit the elevator or if you hit the light switch, which currently don't implement the blueprint interface, but will in a second, then they will use their code. Okay, and so you as the human do not have to do anything more than this. So this is actually really powerful generic use code, right? And you do not really need the player to know about elevators and about light switches and things like that. Nice bright purple, why not? This is good generic use code, okay? And you just put this on every one of your, games really, because it's pretty general purpose, right? You just hit use, and if there's anything that implements usable, which maybe that's a better name, usable. Yeah, maybe that's a better name. Then it'll be used. Okay, so let's show how to do that. Come back up here. Let's change the name from use BPI. I like usable better, maybe usable. Okay. And then again, the name of the action is use. Fine. I guess it's fine. Okay. So here we are in the elevator. The elevator needs to implement the use BPI, and then the light switch also needs to implement the use BPI. By default, if I type use or something here, I can send a message to somebody else saying to use them, but I don't have an event use on me. I don't have a use function on me, and the reason for that is because I'm not implementing the interface. And so what I have to do is I have to set inherited implemented interfaces. Here we go. Usable. There we go. So there's my usable BPI right there. So you have to go click on class settings. Class settings will pull up like who you inherit from and things like that. At the very bottom, you're going to see implemented interfaces. You click add, you type in usable, and well, I've already implemented it, but you hit OK, and then boom, you have it here. Now you'll see, aha, look at this over here. We now have the ability to implement a use function. So if I drag that, if I double click on it, then what will I do? I will say print string, of course. Why wouldn't I? And I will say I have been used, like that. And I will compile and save and run. I've done this for light switch. I haven't done it for. Actually, I don't know if this thing. I don't know if I can actually hit it with a trace line. That's unfortunate. Maybe let's try making this bigger. Chonkosaurus light switch. It might actually just be too small. It also might be set not to receive trace. There you go. I've been used. Great. I think the thing was actually I died. Okay, there we go. Come on, die. Thank you. I did die. Great. Okay. Not do this to me. Okay. So here, and when I get close enough, boom, I have been used. Okay. All right. So what do we do instead when we have been used? Well, we will just do whatever it is we do when we touch it, I guess. So it'll come up to here, half-second delay, and then it'll turn the light on or something. So you can see that's a pretty easy way of like, you can make it turn on when you touch it, or you can make it turn on when you use. Yeah. So every time I hit use, there's a half-second delay, and the light picks a random color. Maybe not a half-second delay. Maybe we'll just do that. It feels a little bit better to not have that delay. There we go. So you just sit there, you just hammer that, and the lights will just change. Okay. Then for the elevator, I'm going to have a similar problem, which is that the elevator's on the ground, and so I'm not going to be able to actually trace line it. Maybe. Maybe I'll just move it up. I like this. Nah, I'm just gonna leave the. I like it just stepping on it, right? But you guys get the idea. Like if I wanted this thing to be, like, I would have to make it so that, it'd be up here and then like thick enough for the player to actually hit it with the use. But what I do is this. It's like inside of here, one more time to make it usable. Go up to class settings, go to implemented interfaces, say this thing here is usable. And then compile, save. Once you do that, usable PPI has been implemented. Then you should be able to double click on use, and then like basically when you use it, have the elevator fly up or something like that. I don't really like that, but okay. Well, let's just make this thing look terrible for 1 second. 1 second. We'll come over here, use it. It's stuck in the ground. There you go. All right, neat. There you go. Yeah, it's I like just being able to step on it, but that's the idea. Like any object. Stop running. Okay. Any object you make in the world can be made usable in this way. So all the player needs to know is when I hit E, I trace line out 2 meters in front of me. Anybody who's usable gets used. And then the objects themselves then are the only people that need to know what happens when you use a light switch, what happens when you use an elevator, what happens when you use a flower pot. Not all of that code has to be on your main player, right? The player doesn't need to know anything anymore about elevators. And also the code gets really complicated because you do a trace line, you hit an elevator, you do this. Else if you hit a light switch, you do this. Else if you hit a player, a monster, you do this. And the blueprint gets really crazy. A blueprint interface is the way to go to cut down on the complexity of being able to use a whole bunch of different things like that. And that is the Mega Light Switch. That is the Chonk Master in Chief. So that is our lecture today. And all you got to do is make a usable. Maybe I'll have you guys make a usable elevator. I'll let you think about how to do that in such a way that makes sense. Maybe a call button or something like that. Think about it. Should be fun. That's it for today, guys. Thanks for coming out. Peace.